Thank you. We'll begin the 3D geometry in the last introduction class. That's what I told. And it's one of the easy chapter. I'm not sure. It's very tough, right? But it's absolutely extension of the 2D geometry. It's absolutely extension of the 2D geometry. I'm sure all the BSc people studied 3D in their graduation. Yeah. And no, acha, great. But I'm not sure all the BTech people studied 3D in their graduation. But otherwise, you studied 3D geometry in the 12th up to the direction ratios, direction cosines, even sort of plane. I'm not sure about the plane, but otherwise, direction ratios, direction cosines might be studied. And that's so fine. And in the two-dimensional geometry, I'll give you absolute introduction and possible nice manner. Never worry regarding that. But what is my experience in this chapter? My experience in the chapter from the people. Okay, so we are understanding 3D geometry, but I'm not getting feeling, right? What sort of feeling you wanted in this subject? It's not any social subject to get any feeling, right? And it's a mathematics, it's a subject. And so there is no emotion, they should not have any emotionality to think these mathematics chapters. Think you are understanding or not, that's more important. Are you really understanding the logic behind the steps? And with this 3D geometry, or this geometry, there is a different orientation of writing. What we do in generally, we write a step, and we express about the sense. Means that from which source this step has written, we'll express in the sense. That sort of information we write in the word algebra chapters. Algebra means that linear algebra, modern algebra, that's what. And the same sort of situation even in the calculus also sometimes, in the real analysis also. So more or less, you know, in those kind of chapters, even in the complex also, we'll write like this. But most of the times, like in modern algebra, absolutely write the step, and besides that step, you write a sense condition. Sense condition says to us from where this step has written. This sense condition is a source. But like in 3D geometry, you can't write a sense like this. You first explain the sense. Okay, since so-and-so equation is passing through this point, therefore we have. That means that you are explaining the step first, then you are writing a mathematical step. That's what the nature of this content. What you think you have to write first. Thereafter you have to write a mathematical step. Right. So that's very obviously possible to understand. Okay. And Imanshu? Yeah, please, you all have to see that any point which in the region, that can be measured by how many axes of references here? 2 axes of references. 2 axes of references. And they are mutually perpendicular axes, right? Any point which in the region that can be measured by how many axes of references here? 2 axes of references. It's very simple. But when I go to the case of this space, any point which lies in the space, that can be measured with at least how many axes of references here? At least 3. But we are studying in our chapter at most 3, right? We are not going to study beyond the 3 axes. The beyond the three axes of reference we study in the linear algebra. In the linear algebra, you talk about even 4 axes also, 5 axes also, infinitely many axes also. That's what I say. But here in the chapter, at most 3 axes of reference: x-axis, then y. Y is going to be inside the board, and then z. And all right, the 3 axes of references, they're mutually perpendicular lines. I can write it is x dash, it is I'll say here y, according to my understanding. I'll write it is z. It is y o y dash, it's z o z dash, already I wrote x o x dash. This x dash, y dash, z dash, they are negative side of the word ox and oy, and then oz. See, you know, this why I took it out, right, for my convenient, just like to see like this. But otherwise my y would be what, like this. So simply you can see my y would be, my y should be like this, but I'm not able to, you know, sorry, yeah, my y would be like this, but I'm not able to draw like this. That's the reason I took like this. Okay, yeah. So next point. So it's x, then it's y, then it's z. When you take a point in the space, which can be measured with at least how many axes here? 3 axes. Okay. But here we are going to study at most 3 axes of references. If that is the case, so fine. Please, why I'll be, you know, drawing like this, I told very clearly, I'm not able to draw inside. That's the reason I took it out. Okay. Next. For my convenience, I'll be dropping out this oy dash, ox dash, and oz dash. Yeah, it's so fine. And it's a O, point of intersection of the 3 axes. I'll take here, it's very simple. The 2 axes of references can divide the region into how many equal parts? 4 equal parts. What are those 4 equal parts we understand here? This is one part, means that I would like to write oxy, another is what? Ox dash y, another is what? Oxy dash, another is what? Ox dash y dash. And each part is known as, everybody knows, but still I am recollecting. You know, each part is known as a quadrant. Next point. If we'll take a point in the region, I don't know, its coordinates. But from that point I can draw the perpendicular to the one of the axes. I draw the perpendicular to the another axis, isn't it? And it's a foot point, is that P dash, it's a foot point is here, P double dash. And from this origin to this perpendicular, what is the length here? You assume x, say. You assume here y. And these 2 lengths will be known as the coordinates of which point here? P. Like the same way you can write the coordinates of which point here? P dash. What is that? X comma 0. Here is what? 0 comma y. That's what you write. If that is the case, so fine. You created here with the P point. You found here with the P point a rectangle or not? That's the reason these axes will be known as a rectangular axis. That's the reason these axes will be known as a rectangular axis. You understand? Next point. When I take a point in the space, carefully mind here, and it can be measured by at least 3 axes. I told, but here we are going to study at most 3 axes of references. I'll take that point in the space like this, isn't it? Yeah. But from this point P, you draw a perpendicular to what? In the region. You draw a perpendicular in the region. How many perpendiculars you can draw? Earlier I was drawing a perpendicular to the axis. You understand? On the x-axis and on the y-axis I used to draw. But here I can't. But before that, I would like to say the 2 axes of references, they were dividing the region into 4 equal parts. They are known as what? Quadrants. I wrote also. But the 3 axes of references can divide the space into how many equal parts? 8 equal parts, everybody knows. One part is that OX, Y, Z, right? OX, Y, Z. And another part, similarly you can write the negative side of the axis also, for X also, for Z also, for Y also. What is that? Blindly I'll be writing OX dash Y Z, OX Y dash Z, OX Y Z dash, OX dash Y dash Z, OX dash Y Z dash, and OX Y dash Z dash, and OX dash Y dash Z dash. How many are here? 1, 2, 3, 4, 5, 6, 7, 8. Then each one of the part is known as what? Octant. How many equal parts here? 8 equal parts. And each part is known as octant. 8 octants. That's what I say. Like here, 4 quadrants. Okay. Second. But I just spelled out one information is that when I took a point in the space and correspond to that point, I can draw a projection, not guarantee an axis. Not guarantee an axis. I can draw a projection of that particular point in the what region? In the what plane region, right? When I have a point in the on my head, the projection of this will be on where? In the region, that plane region. That's what I'm saying. So please, you draw perpendicular to the what? Region. You draw perpendicular to what? Region. You draw perpendicular to what? Region. That's what I'm saying, isn't it? But containing this perpendicular and this perpendicular, can you find a plane intersecting one of the axes? You can. Containing this perpendicular and this perpendicular, do you find a plane? Yeah, you can. And containing a, this, you can find another one, another plane basically. So finally, through this point, I found a what? Rectangular parallelepiped. Right. Through this point, I found rectangular parallelepiped. Online guys and lot of people not able to comment anything. Comment नहीं कर सकते बच्चे. कर रहे? कहाँ देखे नहीं रहे मेरे को? Yeah. Okay. Well, so of course, man, I would like to say, with the P point, with the 3 axes of references, you created what? Rectangular parallelepiped. So that was the reason, again I would like to say, this OXYZ, OX axis, OY axis, OZ axis will be known as what? Rectangular axis. That's what you all understand. So it means that you can see, in future I can say, with the 2 axes of reference I can create a circle. With the 3 axes of references I can create a what? Sphere. That's a different case. But right now we are able to create like this. That's the reason, here I would like to say, since you create a rectangular axis, since you create rectangular parallelepiped, right? Sound badao iska? Yeah, rectangular parallelepiped. That's what I can say. I hope you all agree. Yeah? Well, and sometimes in future I can say, not now. Sometimes in future I can say, not now. The length, of course, I just told, containing this line and this, have I found a plane or not which intersects the axis? And from this point to this plane, how much distance you have? Some A you assume, whose name is X equal to A. But here, in the same pattern, from this plane to this point, how much distance you may have? Some C, whose name is Z, right? You have a word, from this point to this plane, what the length you can have here? B, whose name is Y, you can put up. And these lengths will be known as A, B, C. They are known as the coordinates of which point here? This, I say, P. Of course, I can easily write the point, this P, Q, and R. I'm just writing. It's A, B, then see. I'll easily write the coordinates of the other points as well. Everybody knows. What are the coordinates of this Q point? What is absent here? Z is absent. That means that what do you like to write here? A, B, 0. Would you like to write here? And B and C are present, and 0 B C. What do you write here? X and Z is present, Y is absent. A 0 C. Well, and here A 0 0. Here 0 B 0. Here 0 0 C. That's it. We can easily write. One another point, the plane which is passing through the origin, the plane which is passing through the origin will be known as a coordinate plane. Right. I hope you all agree. And how many coordinate planes you can able to find here? 3. Parallel to this coordinate plane you found like this. In how much length this plane found corresponding to or else parallel to this plane? A length. Then this x equal to A is known as a equation of this plane, which is parallel to what? This coordinate plane. This z is equal to C means that this plane name is known as a z is equal to C, which is parallel to what? This OXY plane. That means that how many parallel planes I can find? Those parallel planes parallel to the what? Coordinate plane? 3. 3 parallel planes as well as the 3 planes which are parallel to the coordinate planes. In total, how many planes you can have? 6. 6 planes together will be known as a rectangular parallelepiped, right? And these planes sometimes known as rectangular planes also you can say, right? So this way things to be taken, nothing. Just we can extend the information from the 2D to what? 3D. Just like if I go into the content sense, Zoom meeting nahi hai, it's not a Zoom meeting, man. It's a YouTube live, right? Yeah. If I go to the 3D geometry contents, very first I would like to see an intro just like a coordinate system. In the coordinate system, what do you study? Distance between the 2 points, and the midpoint of a line segment joined with the 2 points, right? There is a sectional the section point, which is internal division, which is a external division, right? So these kind of intros we would like to see. Just like you generally learn in a 2D geometry, generally learn in a 2D geometry, what kind of things you just try and learn here? I would say distance between the 2 points, or else a midpoint of a line segment joined with the 2 points. But before that, I would like to see the distance between the 2 points to be denoted by AB. A and B are 2 points, and AB bar without any arrow is known as a line segment joined by the A and B. And another notation is that AB bar with one side arrow is known as a line which is passing through what? A and B, right? And if I put up an arrow on both the sides, line is passing through A to B as well as a B to A. These are sort of simple notations, what you all can agree, right? Again, please, we used to see these kind of informations like in 2D. The same thing we can see here also. It does not have so much of importance. In which place? In the 3D. But otherwise you should know of these. Next point. I just told there is a line segment which is joined by what? A and B. I just told there is a point C which may be known as a midpoint, right? And everybody knows. How can I say there are 3 points are set to be the collinear when 3 points lie on the same line? Will be known as a collinear. With the 3 points we generally generate the word vectors, right? Those vectors will be known as what? Coplanar. That's what language we speak, right? In the case of the points we speak about collinearity, right? And of course you can see the collinearity. What is the meaning of the geometrical thing of the collinearity, sum of two distances will be equal to what? Third distance. That we can see in the language of the matrices also. The determinant is equal to 0. That's what everybody knows. Well, and again, if the 3 points are not the collinear, create the word triangle. Create the word triangle. That triangle may be what? Right angled triangle, isosceles triangle, or else equilateral triangle, and so on. You see the conditions between the word, which kind of triangle it is, that's what you can see, right? But same kind of information we would like to see here also, right? Another point I would try to recollect, is that, there is a line which is passing through the point something, or else line segment, that's it. But this line segment is been divided by a plane. You all understand? Well, and but this plane divides a line segment AB internally, but through which point this plane cuts this line segment, some C point. That's it. But this C point satisfies the word plane and lie on the word line segment. That's what you understand. But this plane divides the line segment internally in the ratio m:n. M and n are nothing but distances from A to C and C to B. That's what we would say. But no, sometimes what happens here, I would like to take, this is a point A and then B. I'll take, the point is outside, man, and I'll have a plane like this, okay. But what happens here, from this to A to C is how much distance you can have? M. And from B to C, how much distance you may have? N. And this plane divides this line segment AB externally in the ratio m:n. Again, m and n will be known as the distances, that's what everybody understands. But the same kind of informations I would like to see in the 3D geometry also. Along with this information, in the 2D, you talk about the locus. In the 2D, you talk about the what? Locus. Please, I'm talking about the 2D, because why I'm talking about the 2D, you have already studied this content. That's what my impression to show you, nothing else. I should not want to see this language in the 3D, because it's the same as in a 3D from where? 2D. That's what. Well, when it comes to the case of the locus, I believe locus is okay. Everybody may understand the definition. What exactly the definition of the locus may be here? Locus is nothing but a condition. Locus is nothing but a condition. That condition is being developed by word. The set of all points. The set of all points satisfies the word, the given condition. But what is that given condition? I would like to see. For example, you see there is a point C. And from C point, you can have some distance would be what? Fixed. And with the same distance R, how many points I can really find here? Infinitely many points I can find. And what is the variable point here? P. What is the fixed point here? C. What is the fixed distance here? R. Having the fixed distance from the fixed point, how many points you can find here? Infinitely many points P we can find. Then what is my condition here? PC is equal to R. PC is equal to R. That means that the set of all points which satisfy the given condition will be known as a locus. But this locus will be given by word. This condition. That condition provides us with equation. That equation may be what? A curve form, maybe surface form, or whatever the form, based upon the situation. If I talk in the word 2D, I can get a curve. If I talk in the 3D, I may get a surface. If I talk in the 2D, I can get a circular curve. If I talk in the 3D, I can get what? Sphere surface. That's what I'm saying. So I'm again saying locus is simple to understand. It's a definition, but the structure, the form of the locus is going to be time to time change, and sometimes we cannot understand basically. Just like there is a chapter name called functions. There is a chapter name called permutations and combinations. When you do permutation and combination, it looks so nice, interesting. You're doing something. But after some gap of the time, you forget everything. The same thing is true with the functions also, most of the times. Like in a functions, only one case I believe to say onto. Everybody knows the definition of the onto function. What is the definition of the onto function? If the range is equal to what codomain is an onto. That's the very simplest form of the definition. Otherwise, what is your other way around of writing theoretically? For each element of the codomain, if there exists a pre-image in the domain, then which leads to the definition of what? Onto. But see, the standard definition of onto looks so easy, right? But when it comes to the establishment of any question onto, then that establishment is going to be changed with the time and the situation of the problem. Like the same way, the standard definition of this locus is very easy. But when you establish a locus with the problem to problem, is going to be changed. And sometimes is ununderstandable also. It's a fact. So you should be careful on these kind of aspects. A lot of people won't practice. Like, modern algebra, when it comes to the onto, looks so nice. But establishment of onto is going to be changed, right? With the question to question. It's a fact. Like the same situation occurs with this, right? Yeah, please be careful on this. The same kind of, same sort of informations you study in the intro of the this 3D, where you can talk about coordinate system, right? In the coordinate system, you can try to learn about the distance between the 2 points, or else a midpoint of a line segment joined with the 2 points. Or you would like to say the 3 points lie on a line will be known as collinear. The collinear condition we can also see through by some of the two distances will be equal to third distance, or else you can also see through I would like to say determinant form also you can see, right? And if 3 points do not lie in the same line, will be known as non-collinear, not a collinear. Will make a form of triangle. Triangle may be any kind of triangle you can get, right? If you are going to take a case of the 4 points are not going to lie in a same line, are not going to form the this triangle. You can get the form of rectangle, parallelogram, and so on. Many things you talk about. Okay. And later on you can talk about in this, which system I just told, this locus, that's what we talk along with that. And section point. Section is going to be internally division, or else external division, that's what you speak. Many other points also will generate, but otherwise these are some standard informations what you need to understand. After this, in the 3D geometry, you go for the basically plane. So see, in the 2D geometry, but before going to the 3D geometry, we'll talk something else also. I think everybody knows in 2D, there's a line. Everybody knows in 2D, there's a line. Please, I'm not going to talk beyond the 2D. I'll just show you the 2D, then I'll talk about the 3D, what you already studied, right? So my point of view is here, how simple it is, that's what I wanted to show, nothing else, right? And what is the line in 2D? You would like to write ax plus by is equal to what? See, I would like to write d, right? And this is what a general form of the line, general form, right? General form of the line. Next. And intercept form of the line is what? X by a plus y by b, that is equal to what? 1, isn't it? What are my intercept numbers here? A and b's. Intercept form of a line, isn't it? Next. Y is equal, I would like to write mx plus c. This is known as what? Slope form of the line, isn't it? This is known as a slope form of the line, Right. Carefully mind here. Right. And what is the slope on this line? M. M we can also treat with the word tan theta, which make an angle with the word positive direction of the x-axis. That's what everybody knows. Positive direction. We don't see with what general x-axis. Positive direction of the x-axis. Okay. But see, it's a line in 2D. What I provide here, provided that a square plus b square is not equal to 0. What is the meaning of a square plus b square not equal to 0? At least a and b, or at least one of the a or b not equal to 0. If both are 0, I can get inconsistent. If both a and b are becoming 0, I'll get what? Inconsistent. Absurd. That's what the case. So keep in mind this. But see, I just talk about the last one. In the case of the line in 2D, you can have a slope. In the case of the line in 2D, you can have a slope. But in the case of the 3D, for the line, you can have a what? Not a slope. You can have a direction cosines and a direction ratios. That's what I'm saying. Direction cosines and direction ratios. The slope was which is making an angle with the word positive direction of the word x-axis. But I can also see the cosines and ratios with the word positive direction of the x-axis, then y-axis, then z-axis. I would like to see there. Okay. So please keep in mind that sentence. So if that is the case, please in 2D, so in 2D geometry you can talk about the slope. In the 3D you talk about the word direction cosines and direction of ratios. That's what you would like to see. DCs and DRs. DCs and DRs. It's so important. It's, you know, it's available from beginning to ending. Every time you talk about what? Direction cosines and direction ratios. Right. And then I'll go to the word basically a plane chapter. Right. But see, I just told an idea that carefully mind here. A line in 2D. But it was, you know, referring with what, how many axes here? 2 axes. But when I add the word one more coordinate, right? One more coordinate. What is that one more coordinate? CZ. It becomes a plane surface. It is not a line right now. It becomes what? Plane surface. It's not a line right now. Then what is my condition to be provided? Please you tell me. I can provide a square plus b square plus c square is not equal to 0. That means that out of a, b, c, at least one would not be equal to 0. I'm not writing anything new. Just only. Like in 2D you talk about the word. In 2D you talk about the word. The line which is passing through word. Some point. But can I ask you a simple question from you? In this line, effectively, how many arbitrary constants you have? In this line of 2D, effectively, how many arbitrary constants you have? No, not a 3. Mic do kisi ko? In this line of 2D, effectively, how many arbitrary constants you find here? You tell me online, guys. Write something. अरे माइक ले लो, क्या दिक्कत है?
Hello sir.
Yes, no, कुछ भी बोलो, क्या दिक्कत है?
Sir, 2 sir.
2. Because you know, out of the ABD, you kill one of the result.
Yes.
You write is whole divided by what? So that's what is happened here. That's what is happened here too. That means that how many unknowns in association with this line? 2. To know the 2 unknowns, it is enough to pass through how many points? 2 points. Or it's enough to connection with the how many conditions? 2 conditions. It's enough to connection with the how many conditions here? 2 conditions to crack about what? Those 2 arbitrary constants. That's the reason I can find this line by passing through the 2 points. Or I can find this line by connection with the how many conditions? 2 conditions. That's what I would like to say. किसी ने बोल रहे increase volume, अबे कहाँ देख रहे? So, if that is the case, please, when I write plus, what do I like to write here? 𝐶𝑧. Then what do I express here? 𝐴² plus 𝐵² plus 𝐶². How many arbitrary constants effectively available here? You tell me.
3, sir.
3. That's the reason, in the case of the plane in 3D, in the case of the plane surface in 3D, effectively 3 arbitrary constants I have, right? To know the 3 arbitrary constants, it is enough to pass through how many points? It is enough to pass through how many points? 3 points. Or else it's enough to connection with how many conditions here? 3 conditions. But how that connection? That's what I don't know. That is based upon the situation of the question, right? So that means that sometimes I would like to say 3-point form of the plane, since it is passing through the 3 points through which we can clear A, B, C, or some, maybe sometimes A may be fixed, rest of the 3 are be constants, or else D may be fixed, rest of the 3 constants are arbitrary constants. So anyway, effectively 3 arbitrary constants can work here. That's the reason there is a 3-point form of the plane we can write. Right. For the plane you can see word. For the plane you can see the word in normal. For the plane you can see the word normal. For the normal you would like to find the word direction cosines or direction ratios. So instead of to see the plane in a instead of course, in place of the line in a slope form, we'll see the plane in normal form. What is the plane in normal form? In future I can see the plane in a normal form. The plane in normal form, in future I can see Lx plus My plus Nz is equal to P. This P in future I can say is a perpendicular distance from any point of this plane toward origin. Exactly, just like if you guys allow me, just I show you something, not so much, otherwise I'll show you here. Mic lelo. Himanshu Rao. See guys, it's very simple. There are 3 axes of references you can have. There's a plane, that's what you can find as in general form, right? Second, when you ask me a question that these are 3 axes of references, I can find a plane like this. I'm not sure it's going to intersect anywhere, but this plane name is what this. And from this plane to word, I'll find word perpendicular. And that perpendicular distance from this plane to origin, how much man here, you understand? P. You write the equation of this plane in which form here? Normal form. What is the normal length here from origin to this plane? Is a P. And what are the DC's or else direction question? This normal I may take as LMN. So in future I am not able to explain right now. That's what I'm putting an idea. So in 2D, what do you speak a line? That a slope form of the line you put up. In the 3D, the same thing in the normal form of the plane you find. You can't say there's a normal plane. You speak a language word, plane in normal form. Not to speak a language, normal plane, right? So I hope you understand. Well, so it means that what I'm trying to convey, I'm just dropping it. I would like to write separately that there's Ax plus By plus Cz is equal to D, provided A² plus B² plus C² not equal to 0. What next I would like to write? X by A, Y by B, then Z by C is equal to 1. This plane is known as which form here? Intercept form. What are the intercepts corresponding to x-axis, y-axis, z-axis? A, B, C. Okay? Yeah. There's another situation, just I created something here. Lx plus My plus Nz. That is equal to what? Small p. Small p is known as a perpendicular distance. The length you can write. And these elements will be known as direction cosines of this particular normal. In the name of the normal we can write, we can express the plane. That's it. So that's the reason that's called a normal the plane in normal form, that's what we speak a language, right? Secondly, I just told in the 2D, I'm just comparing with the 2D, I'm not doing anything new here. Just my point of view here to see how it's easy. That's what I'm thinking to say, nothing else. Yeah. And next point, in the 2D, not only these forms you can learn, in the 2D, not only these forms you can learn, and you told that there's a line which is passing through 2 points, but I told that there's a plane which is passing through the 3 points and all, right? Normal form, and then what? Intercept form, this that I told. Here is the general form, intercept form, and slope form. That's what I spoke. In the 2D, you talk about angle bisector lines, right? What is an angle bisector lines? And is that very simple? You talk, there are 2 lines I may have, right? And there's a third line. There's a third line. It's a 1, it's a 2. There's a third line. It is nothing but angle bisector line. This make an equal angle with what? Line 1 and line 2. And when it makes an equal angle with the line 1 and line 2, therefore this line 3 will be known as the angle bisector line between the 2 given lines. Angle bisector lines, angle bisector line between the 2 given lines. That's what you all understand. But how many angle bisector lines you find? Only 1 or 2? Yeah, you can find 2 in a way that I can extend this line like this. Then I can find what here? It's a 4. The 4th line is nothing but again angle bisector line. It is what I can say it's a 1, it is a 2. It is what I can say 1. Okay. This 3rd line is angle bisector line between the 2 lines 1 and 2. 4th line is also angle bisector line between the line 1 and 2. If the 3rd line makes between the 2 given lines is acute angle. Is acute angle, acute angle. Is it less than 90 degree or greater than 90 degree? Less than 90 degree. If the 3rd line makes an acute angle between the 2 given lines, then 4th line makes between the 2 given lines is a obtuse angle. Obtuse angle. I hope you understand. So this 3rd line and 4th line will be known as angle bisector lines. Angle bisector lines. But the same extension of the angle bisector lines between the 2 given lines is in the what? Angle bisector planes. If I go to the word, now you forget about the line to read. And one plane 1 and plane 2. And plane 3. And then plane 4. Isn't it? Now the 3rd plane is known as what? Angle bisector plane between the 2 given planes. 4th line is nothing but angle bisector plane between the 2 given lines. But how many angle bisector planes I can find here? 2. Between the 2 given planes. So if a 3rd plane is angle bisector plane between the 2 given planes is with the acute, then 4th is obviously obtuse and vice versa. That means that nothing is different from the 2D to 3D, just extension I'm putting out, nothing more than that. Yeah, I hope you agree, isn't it? So, in the plane, you talk about the what? I recollected in the plane. What is the general equation of the plane? What is the, intercept from the plane? What is the normal from the plane? And general equation of plane is passing through how many points in generally? 3 points. That's called, that's what we call as a 3-point form the plane, and so on. And by the way, I started recollecting how you said it's intercept form. Which one? This one. How? It's intercept form. I'm just comparing it from the 2D to 3D. Right, what are the intercepts here? A, B, C, along the what? X-axis, Y-axis, and Z-axis. Isn't it? You need to have an idea. This much of the basic idea you need to have. Okay? Yeah. Second, I was trying to say about the what? Angle bisector planes I told. Along with that, have you heard in the 2D geometry, along with that, have you heard in the 2D geometry, pair of straight lines? Pair of straight lines. You might be heard the pair of straight lines. Okay, I still use this. You know, I'll write pair of straight lines in 2D. Please just observe my things. I'm not doing anything new, right? Okay. And in the case of this, all right, ax plus by, all right, plus c, or else I can write is equal to 0. Next one is what? It's a line 1 and line 2, a1x plus b1y is equal to what? 0. But both the lines are really passing through what? Origin. Both the lines are really passing through the origin. The pair of these two lines, you will express as with what? Ax plus by and multiplication with what? a1x plus b1y, a1x plus b1y is equal to 0. Isn't it? Yeah. X by a, no, x by a plus y by b plus z by c. कहाँ है? Is equal to 1. If you write x by a plus y by b plus z by c is equal to 0, that is passing through the what? Origin. That's what I'm saying. Yes, that form is known as intercept form. How many? Ax k by square 2hx. Yeah, it's correct. Generally, it will give the form somebody was already writing, right? A to x square and 2hxy and b to y square. Do you get this form or something else form? This form only. You'll get x square term, you'll get xy, and you'll get a y square term. So this form is coming out to be like this, isn't it? Yeah, you can understand. Observe it very well. Next point, what I'm trying to say. Then, you know, this equation is known as, or this equation is known as a homogeneous equation in terms of x and y. This equation is known as homogeneous equation, in terms of x and y. It represents what? This equation. This equation is represented by what? These two equations. That's the reason this equation is known as what? Pair of these two planes, right? These two planes. That's what. Yeah, it's okay. That's what. But no, it's not necessary for me that to take passing through the origin. You can also take with word, L1 line, ax plus by plus c is equal to 0. Another one is what? L2 line, a1x plus b1y plus c1 is equal to 0. From these two, I can club. I'll get the word ax plus by plus c into what? a1x plus b1y plus c1, that is equal to 0. When I really express, what happens here? Can you tell me? You can have a to x square, you can have an equation is x square term, you can have the word hxy also you can have, something like I will write 2hx y. Another you would like to write word is that b to y square you have, okay, all second degree terms I wrote, and again I'll write here c2, I can have x term, I have a c3 or else d2 y term, I can have the word e2, that is equal to 0, isn't it? That means there is not a homogeneous equation. It is a homogeneous. Which one this is? My all terms degree remain same. Otherwise, in the other way around also you can say for homogeneity to create, it is passing through what origin, but it is not passing through the origin. It's not a homogeneous. All terms degree is not the same. But we can convert this into the homogeneous. We can shift it to the word homogeneous by creating what? One more variable. That's it. So that's what we learn in the word basically, in the 2D geometry. But the same thing we can extend it to the word 3D. Pair of planes. So what are my pair of planes? What are my pair of planes to write? Maybe passing through the word origin. Please, I'm not doing anything new here. I'm just comparing. So you feel confident, or you feel, bad in the sense of what? Okay, I'm not able to recollect of my studies, but I've studied in the previous. You have to feel like that bad, right? If you're able to recollect, it's good. Vaibhav, क्या बोल रहे हैं? इस equation के delta 0 होगा. Then only then pair. Yeah, I'm not putting up the condition. I'll tell you the conditions in 3D. Right, don't worry. Right. I'm just able to recollect. Okay, we have studied this kind of content in the 2D and all. That's what I'm able to recollect. But I'll tell you conditions in 3D also. What are those conditions? I'll tell you nicely, don't worry. Yeah, here, P1. What does the P1 represents here? Plane, right, 1. Isn't it? A1x plus B1y plus C1z is equal to 0. A2x plus B2y plus C2z is equal to 0. These two planes are passing through what? Origin. Isn't it? What is the pair of these two planes? Alright. The pair of these two planes are nothing but here, A1x plus B1y C1z multiplication with what? A2x plus B2y plus C2z is equal to 0 finally. This represents, if you allow me, this represents ax square plus by square plus cz square 2gzx and 2hxy plus 2fyz is equal to 0. Say, isn't it or not? Or I'll get x square term, I'll get y square term, I'll get the z square term, I'll get xy term, I'll get xz term also, I'll get a yz. That's what I wrote, nothing else, nothing more than that I'll get. Okay, Yamani, correct. Well, it is also homogeneous equation or not? Yes. Passing through the word origin. It represents what? These two planes. Since I wrote these two planes together like this, and this equation means that this equation is known as what? Pair of planes. Right. What are the planes here? Give this. But to say sometimes, this equation in reality represents these two planes. To know that, I'll put a condition here. Okay, Vaibhav? Right. What is the condition? I would like to write AHG, AHG, BC, FF is equal to 0. If it is equal to 0, what next you have to remember? That is, what do I mean? ABC plus what I remembered? 2FGH minus F square minus B square minus CH square is equal to 0. Will you get this only from this determinant? You might not be remembered. In the 2D also same thing we will see. But why should I say in 2D? Better I would say in 3D the same thing. If this determinant is equal to 0 from this equation, you'll easily remember AHG, AHG, BC, ABC, FF, AHG, 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 ABC, FF. Can be remembered easily. Or else you can write, when I open this determinant, I'll get ABC plus 2FG minus F square minus B square minus A square is equal to 0. Yeah. If this determinant is equal to 0, then this equation represents these two planes. And this equation is known as the equation of the pair of planes. Equation of the what? Pair of planes. That's what. But these two planes are passing through what? Origin. It is what? A homogeneous equation. The same equation I speak to the word cone in future. This cone with vertex at origin. The same equation I speak in the word chapter cone. But cone may not be what? Cone may not be what? May not represent the pair of planes. But this equation may represent or may not represent the pair of planes, but represent always a cone in future. But this equation represents a cone when this condition holds. But I'm not showing how this condition holds right now. I'm just able to recollect. Right. And that means that what I'm trying to say, okay, we are going to study up these kind of contents. That's what I'm trying to say. But the same thing, I'm just copying, pasting, nothing else. Here also you can study. अरे इसका फोटो भेज सकते क्या? भेजो. इतने ही भेजो रफ. नहीं सारे. इसको उड़ा दीजिए. Yeah. See, I'll take another plane which is not passing through what? Origin. What is that? a1x plus b1y plus c1z plus d1 is equal to 0. a2x plus b2y plus c2z plus d2 is equal to 0. These two planes are not passing through the what? Origin. Origin. Isn't it? And again, from these two I can combine. What is that combination or combine equation here? a1x plus b1y plus c1z plus d1 multiplication with the second equation a2x plus b2y plus c2z plus d2, that is equal to 0. But from this equation I can get a situation. From this equation I can get a situation is that ax square by square cz square 2zx 2hxy 2ux 2vy plus 2wz 2wz and plus d, that is equal to 0. You will get x square term, y square term, z square term, xy term, yz term, zx term and x term. How do I get x term? a1x into d2, that's x term, right? And I can get the what? Y term alone, z term alone, you'll get what? Lastly constant also, right? So this way you can get. But this equation is not a homogeneous because my all terms degree is not the same. Because my all terms degree is not the same. I'll have some second degree terms, I have a first degree term, I have a zero degree term. But otherwise I can convert this into what? Homogeneous. I can transfer this into what? Homogeneous. That means that when, which term? Y. It's a Y term. xy, zx, xy, okay. x के बेस के 2zx, 2hx पे 2fyz. 2fyz, okay. Well, yeah, condition is that Pragnan Misra. No, I'm not putting up, this h square equal ab, f square is equal bc. That is a different case. Parallelism, pair of planes are going to be the parallel and all. and when two planes are going to be parallel and all, that you know, those kind of conditions we are going to take. Okay? We will not put those conditions here. Whatever you are putting up the condition as 𝑘 equal AB, F square is equal BC, and as G square equal to some AC, these conditions are also there, but those conditions are not applicable in this place. That's what. Yeah. Yeah, next point, what I'm trying to say, but this condition will find in a pair of planes only, but not at this place. Okay. You know what I'm trying to say? We shift this into word homogeneous, and we'll again try to look at the word. Same condition, HG, HG, and BC, FF, determinant is equal to 0. If this holds, and this equation represents what? These two planes. Because on which sense I'm trying to say this matter? I'm saying this matter, I can able to shift this equation into the word homogeneous. Then I'll check this condition. If this satisfies, I would like to say this equation represents these two. But here, you know, along with these situations, what is an angle between the two planes? But I can't see directly these two planes. I can see in the name of these two planes. I can see in the name of these two planes this equation. What is an angle between the pair of planes? Right? I can find a sin theta, I can find a cos theta, I can find a tan theta, where in those situations I may get a situation of the word parallelism, perpendicularism, as well as I can get some condition somebody was writing, H square equal to AB and Y square equal to what? Not greater than or equal to, actually. H square equal to AB, F square is equal to that BC, and G square equal to AC. Equal to I can get. Okay. So that means that we not only see these direct informations, we can also see about something related to what? Angle between the two pair of planes. We'll find the tan theta, sin theta, cos theta, and all. That's it. So that's the situation. You all understand. Well, yeah. Please, more or less, this kind of information we study in the what? Plane. This kind of information we study in the what? Plane. I'm not recollecting everything, but I'm recollecting something what you studied. That's it. From where I'm just recollecting this information. Yes, non-homogeneous. I told that there is a non-homogeneous, but that non-homogeneous we can convert into what? Homogeneous by something, you know, for some procedure. That's it. But right now I can't recollect that. Okay. Yeah, but how to convert the non-homogeneous to what? Homogeneous. Well, secondly, after having the plane, I'll go to the word straight line. Straight line in what? 3D. Straight line in 3D. But see, I would like to say, in 2D you have a straight line with equation. In 2D, straight line you have with the equation. हिमांशु इधर आ सकते हैं, इसका फोटो भेजो. इसको माइक दो एक बार. In the 2D you have a straight line with an equation. Carefully minded. हाँ बोलो.
So what does this imply? If the determinant is equal to 0, then what?
No, I find from this kind of condition by using properties of the matrices.
Okay.
I'll not get directly like this.
Okay.
I've not told the background information. I told only information what you studied in 12 somewhere. Right. And this kind of information can't come directly. You can get what? There's a determinant. The product of the two determinants is coming out to be what? 0. And row by column you multiply, or row by row you multiply. So you will see this kind of, or you will get this kind of equation. Right.
We have reduced this equation into this determinant form.
Ah, yes, it's possible. It is possible. But guys, you all remember, I'm not discussing the chapter here. I'm giving a background of the chapter. right? So it means that you all understand that, okay, what background we have, and in this chapter, that's what we have to recollect. Ankesh. Yeah, well, let's go down. That, information comes from the matrices, knowledge. I just told somewhere, in the 2D, you have equation for the line. In the 2D, your ax plus by is equal to what? D. It's a line. It's an equation. It is an equation, you remember. Provided that a square plus b square is not equal to 0. That's what you are writing. Mean that, not all a comma b 0. At least one would not be equal to 0. At least one would not be equal to 0. You all understand. Well, second, this line I was writing in a slow form. I was writing this into the word intercept form in the 2D. But I was comparing this information of the line in 2D just by small extension became a plane in 3D. Where in that plane you are trying to say the plane in general form, the plane in normal form, the plane in what? Intercept form, right? In general equation, the plane, effectively how many arbitrary constants you have. That's what you are looking for, right? And you've seen through also. Well, you've been recollected them as well. Well, but see, I just want to recollect in 3D with the 3 axes of references, right? With the 3 axes of references. I'll take a line in space. But this line not guarantee of parallel to of any of the standard coordinate axes. This line is not guarantee of parallel to what? Any standard coordinate axis. May be parallel, may not be parallel. That's what you all understand. Okay. Next point. The lines which are not lying in the same plane, and not intersecting will be known as a skew lines. The lines which are not intersecting, not lying in the same plane will be known as a skew lines. Okay. But how do I find? Of course, one line is going, see, just wait. One line is going from up and one line is moving from down. So these two lines nowhere to intersect. When those two lines nowhere to intersect and not lying in the same plane will be known as skew line. Just like take an example of the flyovers in the city, right? Skyways, there are flyovers in the city. Flyovers in the city, you can see one flyover is going from upward and another is from downward. They are nowhere to intersect. They are called as skew lines, right? So how do I find an angle between these two skew lines? You find correspond this one line, correspond this another line. Mean that this line is a parallel to what? This, and this line is a parallel to the another. That means that you can try to find there are two lines which are parallel to the two skew lines. The angle between these two skew lines will be given by angle between their corresponding parallel lines. The angle between these two skew lines given by angle between their corresponding parallel lines. That way you find. Well, if I found a line in a space, but that line in a space not guarantee of intersecting any of the original axes, are not guaranteed to what, parallel to what, any of the axes also, or not guarantee of what, line the what, the plane, the same plane where x-axis lies, or where y-axis lies, where z-axis lies. So it means that this line L and OX axis, or this line L and OY axis, and this line L and OZ axis, they are not necessarily lying in the same plane and not required to guarantee to intersect. And that's what I'm trying to say. That means that this line L and OX not necessarily what? Lie in the same plane, not necessarily intersect. That's the reason I may consider these two lines as what? Skew lines. But how do I find an angle between this line and this OX when they are skew lines? I can find a line which is parallel to what? L. So something like that. So I can find here an angle between this, it's L dash. This OL dash and OX will be something like alpha. The same angle will be done by what? L line. Because my OL dash is parallel to the what? This L. Since this OL dash is parallel to the L, when my OL dash, which makes an angle with the positive direction, the x-axis, an angle alpha, the same alpha will be done by what? L. That's it. That's what I'm trying to say. I just ask you a question, man. You all understand. Between this OL dash and OX, what do you find? Cos alpha. Between this, if you want, I can really interested to explain something. Yeah. Explain something. Carefully mind here carefully. Right? See, I just told man nicely the possible nice information here. I'm not sure I can find directly an angle with the L and OX, L and OY axis, L and OZ axis. I'm not sure I'll be able to find an angle, but I can find an angle for the L with the OX or with the OY or with the OZ with the help of what? OL dash. Since OL dash is parallel to what? L. Okay. But I just ask you another question with you that please, my OL dash is like this. Okay, somewhere my L is somewhere here. I hope you understand. But when my OL dash is here, but my OL dash is having some point P. My OL dash is having some P point. I don't know the coordinates of the P point. The coordinates of the P point you all understand with the positive direction x-axis, y-axis, x-axis. With the x-axis, y-axis, z-axis, you can find the word x, y, z. Have you found or not in the rectangular parallelepiped? How do you find the coordinates of the point? That's what I told. This x, y, z will be known as the distances, right? From the origin to what? Planes. That's what I told somewhere. Well, next point, I just ask you a simple question. From this P point, you can draw a perpendicular. Perpendicular to the what? Some plane. What is that plane? Maybe xy, maybe yz, maybe zx. I don't know what is this plane. It may be xy, it may be yz, it may be zx. When I draw a perpendicular, somewhere in the oxy, for example, what happens? It's a foot point is something like a p dash. I hope you all agree. But do I ask you a question? This pp dash, will it intersect with the x-axis? This pp dash, will it intersect with the x-axis? अच्छा एक ही को दे रहे बार ये क्या बात है उसको दो उन्हीं को दो this pp dash, will it intersect with the x-axis? That's what my question.
Yes.
No. Is my p, is my downside, this foot point is a p dash. There, where is my x-axis? Where is my y-axis? Nowhere to connect it. It means that जो दिखता है वो हमेशा सही नहीं होता है. समझ रहे ना बात? It is a truth which is proved, right? And you always cannot imagine जो आपने देखा वो सही है, right? So what has happened here? From P point you've been drawn the word perpendicular is a PP dash to the xy plane. But this perpendicular is nowhere to intersect with what? X-axis, y-axis. It may be accidentally intersect, but it may not be always. That's what I'm saying. But can I ask you the question? Can I ask? It looks intersecting, but it's not that. Containing the PP dash, do you find a plane which intersects the x-axis? Yeah, it's very obvious. Containing the PP dash. You'll find a word plane which intersects what? X-axis. Can it possible or not? Yeah? But now it may intersect at A point. From this O to this plane, how much distance you have? X. Similarly, you can see with what? Y. Similarly, you can see with what? Z axis. Isn't it? Okay. So, well, carefully mind here. I'm not doing so much. Yeah. This length you can assume as what? R. This length you can assume as what? R. Which length? OP length. And from this origin to this plane along the x-axis means that up to this A point. It's not this plane. Up to the A point. Length is how much here? X. Between this, what do you like to find? You tell me here. Cos alpha. What is cos alpha? You tell me. X by R. Isn't it? X by R. Cos alpha. And when I really work it out with the word positive direction of the word y-axis, that is a beta, positive direction of the word z-axis, that is gamma. If that is the case, I would like to write, what do you write, man, here? Cos beta. What is the cos beta? You tell me here. Y by R. Similarly. I'm not showing completely. Right. Cos gamma, I would like to find here. Z by R. Isn't it? Yeah, so obvious. So, these are known as cosines of which line here? OL dash. The same cosines will be applicable to the what? L. Can you all agree? Yeah. This is what we learn in a very basic class of 3D geometry. Of course, accidentally I've shown it. Okay. But see, I just denote them. Carefully in mind here. L, it's M, it is a N. If you allow me, I can write your x is equal to LR, your y is equal to what? MR plus your z is equal to what? NR, isn't it? Is it not? Yeah, it is. Next point. What I'm trying to say, what is the OP length, you tell me? Your OP length is equal to what? R. So what do you speak here? Under root of what? X is k plus, y is k plus, z is k, that is equal to R square. When I put all these informations here, what do I really get here? LR whole square, MR whole square, plus NR whole square. That is equal to what? R square with the under, it's R square. That's it. Finally, I'll get the word L square plus M square plus N square. That is equal to 1. These elements are known as the cosines of this OL line. OL dash line. They are same as the cosines of which line here? OL line. That means that sum of the squares of the cosines always equal to 1. Okay, next point. I would say when I extend this L dash line in opposite direction, okay, sum P1 I can get. What is this length remain? Same. But now you can observe when this line OP, which makes an angle alpha with the positive direction of the x-axis, but this OP1 to what OP, how much angle you can have? 180. From this OP1 to what x-axis, what 180 minus alpha. Can you agree or not? Tell me very quick. OP1 to OP, how much angle you have? 180. But OP1 to positive direction of x-axis, how much is here? 180 minus alpha. What is here? What do you get here? Cos of 180 minus alpha. Next, what do you get here? Cos of 180 minus beta. Similarly, cos of what do you get here? 180 minus gamma. What do you get here? Minus cos alpha minus cos beta minus cos gamma. What do you get here? Minus L minus M minus N. That means that for one direction from O to P, you have elements. For its opposite direction is becoming what? Minus L minus M minus M. Isn't it? So if you have a direct line like this, it can have a what? Elements, some DCs, and its opposite side, what is going to be happen? You tell me here? Minus L minus M minus N. Isn't it? So for every direction you have one set of cosines. It's opposite direction, same cosines you can have with this opposite in a sign, you all understand. Well, yeah, this is what one basic information regarding what, direction cosine, direction cosines. That's, I have not gone to the ratios. I'll tell also about that. If that is the case, I'll be coming to this straight line. I'm coming to this straight line. Straight line. In 3D, what is peak? X-axis, Y-axis, Z-axis. Okay. Then it is a line L I would like to see. Okay. It's okay. An anti-clockwise, clockwise, that's fine. Based upon my axis, I generally take an angle. I told about my axis. Okay. Yeah, you're right. I agree, Amit. Next point. I will take in reverse. That I agree. Okay. But between that, what is an angle I assume there? Alpha, beta, gamma, something like that. Yeah, okay. There is a line. This line L, which is passing from where? Some x1, y1 and z1. Well, next point. Next point. I'll take, there is a variable point. I don't know what is that variable point. I don't know what is that variable point. P, X, Y, Z. P, X, Y, Z. Isn't it? But this point is not a fixed point. Fixed point is that A. And P is known as a variable point. What is the distance I have here? Some R. But that means that when I have a P is a variable point, obviously my distance is also what? Variable distance. Variable distance. I'll ask you a question from you, all of you, that you can have a line L like this. It is passing. Idhar aao. Manju. You can have a line. इसको ऐसे पकड़ो, कैसे ऐसे पकड़ो. I have a line like this. What is the name of my line? Is a L, which is passing from where? I assumed fixed point A. And on this, how many points you have? Infinitely many points. They are represented by what? P. That P is known as a variable point. But from this A, do you able to find? From this A, do you able to find a projection? From the which point? A point. To which plane? Some plane. That's your wish. And again, from variable point also you can find a projection into some plane. Isn't it? So if that is the case, man, you all have to understand. But you may get a one doubt here. But you see that how the doubt is to be raised. Carefully mind here. But थोड़ी देर पहले मैंने बोला जो दिखता है वो हमेशा सही नहीं होता है. Again, it raises over here. You draw a perpendicular from which point here? A point. It's into any plane you can find. In which plane I'll be finding here? XY plane. That's what my assumption. Okay. And again, from this variable point also you can find, right? Projection. That's what I'm trying to find. But see, these projection lines, will they intersect tau? Will they guarantee to intersect any of the axes here? No. But containing this projection, I can find what? A plane. Intersect the what? X-axis. And containing this also I can really find, intersect the what? X-axis. Isn't it? Next. Now, it intersects at one point, that's what you understand. And from this point O to this plane, how much distance you can have here? x1. From this point O to this plane, what is the distance you can have here? X. But between these two planes, what is the distance you can have here? X minus x1. X minus x1. Can you all agree of this? Yeah. Next point. My doubt question, or else you may get a doubt that if you draw a perpendicular from O to what? This line, this is something like R. This is not a perpendicular to this. This is a perpendicular to what? This projection line. Isn't it? And what is this AR distance? Can you tell me? What is the AR distance? Can you tell me here? X minus x1. My doubt question is here. This AR line and x-axis, will it be really parallel or not? This AR line and this x-axis, will it really parallel or not? Online guys, express. Really, it's a very big question. Go and consult the NCERT at this moment, right? If you really want to see. जो दिखता है वो हमेशा ट्रू नहीं होता है, राइट? इधर आओ, सोच समझ के बताओ. You all can observe and see so carefully. This is what my line. What is this line? This. Okay. I've drawn the word perpendicular. This perpendicular is like this into one of the plane. That one of the plane luckily I chose here into the xy plane. It's not necessarily xy plane. It's in some other plane also you can. इसको ऐसे पकड़ो, यही पकड़ो, यही पकड़ो, ऊपर पकड़ो, right? Yeah. उल्टा पकड़ो थोड़ा. Yeah. Now you can see, man. This is another line. It's okay. I found a what? This is a perpendicular. What is it? Perpendicular AR. अरे AR ऐसे पकड़ो, AR. ठीक है? Now you tell me this AR, is there an evidence of this AR is a parallel to any of the axes? No, it doesn't look. But otherwise I confidently told that containing this line, containing this perpendicular, I found a plane whose distance from origin is what? x1. And containing this line, I found a plane which is intersecting with what? One of the x-axis whose distance from the origin is what? x1. Online guys, tell me very carefully, जो दिखता है वो हमेशा true नहीं होता है. It is proved by here. Can you all agree? Agree with me? For this you have to go and learn the basic. It's okay. So anyway, guys, you all understand. Now, if I talk about कभी कुछ आर्गुमेंट ऐसा होता है, इट इज़ ट्रू बट मैथमेटिकली ट्रू नहीं है. ये क्या बात है? इफ इट इज़ नॉट ए ट्रू बाई मैथमेटिकली, इट इज़ नॉट ए ट्रू ऑलवेज, राइट? कैन यू बिलीव दिस? कुछ लोग ऐसे बोलते हैं बट इट इज़ ट्रू बट मैथमेटिकली ट्रू नहीं है. ऐसे कैसे नहीं होते हैं? मैथमेटिकल ट्रू नहीं तो ट्रू नहीं है. मानते नहीं मानते? जल्दी बताओ. कैन यू ऑल अग्री? इफ इट इज़ नॉट ट्रू बाई मैथमेटिकली एंड इज ऑब्वियसली नॉट ए ट्रू इन जनरल ऑल्सो, कैन वी बिलीव दिस? कैन वी से दिस? क्या हो गया? किसी ने क्या लिखा? ईमान से पढ़ो इसको. हाँ, अच्छा, संस्कारी. ओके. बच्चे कैसे नाम लिखा? अच्छा लग रहा है. या यू ऑल एग्री? वेल, आप लोग को परेशान तो नहीं कर रहा हूँ. अरे मैं तो बेसिक सिखा रहा हूँ. मैं तो क्या है चैप्टर में असली में, राइट? सर ट्रू इन सेकेंड. ओके. एंड इट्स अ फैक्ट. No, just it is introduction class. I'm not doing any content here. So well. I'm not going any deeper. I'm just touching up the information what you studied. Okay, याद है नहीं आपको? बस यही तो बात कर रहा हूँ यहाँ पे. Yeah, between these, what angle you assume? Please, you tell me. Suppose alpha. What happens here? You tell me. X minus x1 by r, isn't it? What is this name? You can say cos alpha. Similarly, cos beta. Y minus y1 by what? Same r. Cos gamma. Similarly, you can get cos gamma. What is that? Z minus z1 by r. So what do I speak finally from this information? This name I would like to notate that L, then M, then N, isn't it? Yeah. किसी ने बोल रहे असली क्लास कब, मतलब रियल क्लास कब से होगा? ये तो रियल क्लास ही है, झूठ वाला क्लास थोड़ी है. वैभव, अगर ये समझ में आ रहा तो रियल क्लास भी आपको समझ में आता है. ठीक है. Next, what do I speak here? X minus x1 by L, and what next here? Y minus y1 by M, Z minus z1 by N. That is really equal to what? R, isn't it? But in reality, this line is represented by how many equations here? You tell me. 3. 3. But in 2D, line represented by only one equation. But in 3D, line represented by equations. How many fractions here? 3 fractions. With the 3 fractions, you'll get what? You know, the 3 fractions is equal to what? R. This R is what? Variable distance. Is it a fixed distance or variable distance? Variable distance. R is to be known as parameter. R is to be known as a parameter. It means that I can say that this line is represented by how many equations generally? 3 equations or 3 fractions. And what are the 3 equations I would mention here? X minus x1 is equal to LR. Y minus y1 is equal to MR. Z minus z1 is equal to NR, isn't it? This is implying X is equal to LR plus X1, Y is equal to MR plus Y1, and Z is equal to NR plus Z1, isn't it? Where R is known as what? Parameter. And these equations are known as equations of the line, right? These equations are known as equations of the line, and in this line, what is R is a parameter. It is a parametric form of the line, right? It's a parametric form of the line, isn't it? And it is a symmetrical form of the line. It is a parametrical form of the line. There is a general form of the line also we speak. What is the general form of the line we speak? 1 minute, give me a chance. You know, these two are the planes. Then what is the general equation of the planes we speak? What is the general equation? Let's go down. The general equation of the plane, or line. General form of the line is that I would say that Amit, क्या लगेगा, if perpendicular from one plane to the another plane, parallel planes होंगे ना? हाँ, that's what we'll see later. It's okay, just give me a chance. I'm putting away information. You're right. Yeah. You know, general form of the line. What is that? You know, a1x plus b1y plus c1z plus d1 that is equal to 0 and a2x plus b2y plus c2z d2 that is equal to 0. Isn't it? These two planes together represent a line or not? Yeah, these two planes together represent a line or not? Yes. This line is known as what? General form of the line or general representation of the line. Right. And again, no, I was writing. Of course, somebody was writing x equal 0, y equal 0 is also line. It's represented by one of the axes. What is that axis here? Z axis. You see, you can write. You know, if it is x axis, it is a y axis, it is a z axis. These two planes, what is the name of this plane, you tell me? XZ plane. In XZ, what is absent? Y is absent, y is 0. This plane is known as the XY plane. What is absent here? Z absent. And this x axis is represented by what? Y is equal to 0 and then what? Z equal to 0. It is known as a line. That line is known as what? X axis. Isn't it? And so on. You write other equations as well. That means that you understand, you know, the line is represented by two planes. Two planes together represent a line, right? But in 2D, you always speak a line is having equation. But in 3D, line is getting what? Equations. The line is getting what? Equations. It is what? General form. Or else I can say in future, unsymmetrical form. What's the name? Unsymmetrical form. That's what I say. Well, and that means that you can say here, or else I can say unsymmetrical form. Symmetrical form. And another one I would like to say symmetrical form. Form of the line. Form. What is that? I just wrote somewhere x minus x1 by L, y minus y1 by m, z minus z1 by n. That is equal to r I wrote. That is equal to r I wrote, isn't it? Next point. There is another form is that parametric form. Parametric form. What is the parametric form of the line? If you say me, this r is a variable number or not? From where fixed point x1 and z1 to what? Variable point x, y, z. Is that x equal to LR plus x1? Y is equal to MR plus y1? Z is equal to NR plus z1. And R is a parameter. R is a parameter. Isn't it? So finally, what I'm saying, line in 2D is having equation. What is my conclusion here? But line in 3D represented by equations. Of course, these are some standard situations I told. Otherwise, other way around discussions also we have. Yeah. You know, again, what I speak, you can have what? Angle between the two lines. If the lines are going to be parallel, if the lines are going to be perpendicular, so these are the cases we can talk. The lines which are known as the skew lines, I just told. The shorter distance between the two skew lines is known as what? Perpendicular distance. Any distance is not going to shorter distance. The shorter distance between the two skew lines will be given by what? Perpendicular distance. What are the equations of that shorter distance line? This is one of the important questions. Right? What is the, what are the equations of the shorter distance line? Mean that SD line. Right? What is that SD between the two skew lines? Skew lines mean that the lines which are not intersecting, not lying in the same plane will be skew lines. What is the shortest distance between them? Basically, we talk as a, perpendicular distance. That's what we say. These kind of properties we talk. Along with these properties, we'll also talk about something else. Three planes together. What are the three planes together? I would say, I'll write plane 1, a1x plus b1y plus c1z plus d1 equal 0, and a2x plus b2y plus c2z plus d2 is equal 0, and pi 3 a3x plus b3y plus c3z plus d3 is equal 0. These are the three planes, right? These are the three planes. And basically, three planes together in a common point. Three planes may be together. You can't imagine these are the lines. The three planes together, pi 1 plane, pi 2 plane, pi 3 plane. Three planes together may be in a common point. It's very obvious. Just like, 1 minute, give me a chance. कोई box है क्या? See guys, you all understand. You're right. This is a plane. This is one plane. This is another plane. This is a plane. 1, 2, 3. They may be together in what? Common point. Common point. When they may be together in a common point, but no two planes are parallel, isn't it? No two planes are parallel. And no two planes not guarantee a word perpendicular. Accidentally may be perpendicular, but not always perpendicular. Of course, these two planes are perpendicular when you see the box. Right. These two planes are perpendicular when you see the box. But it is not guarantee always. But better sentence is that no two planes are parallel. That is the right sentence. But maybe perpendicular. Okay. And like origin, somebody was saying, correct? Like, see, this is one plane, this is another plane, this is another plane. The three planes together in a common point of origin. It's one particular case. Otherwise, in general, also you can have. Right? Next point. You see, very simple. Next, another point. This is one plane, this is another plane, this is another plane, right? And three planes together in a common line. Three planes together in a common line. Right. Three planes together in a common line. But it's not that you can't see these two planes are parallel. You see like this. Because I told a condition is that no two planes are parallel. But no two planes are parallel. No two planes are parallel. No two planes are parallel. But they're together in the what? Single line. They're together in the word single line. That's what you all understand. Plane 1, plane 2, plane 3. Isn't it? That line is what this. Okay. No, sometimes what happens, I just simply convey here that, you see this is a plane. And you see another two planes, the other two planes. These are two planes. This is one, another one, right? And three planes together is what? Triangular prism. The three planes together is what? Triangular prism. Are you not getting a prism? Yeah. The common line of the two planes is parallel to what? Third plane. The common line of the two planes will be parallel to what? Third plane. I hope you agree. So this is known as what? Triangular prism, you understand. And that's what I can try to write. Anytime question may come from this also, but this kind of content you may have, right? So this line is a parallel to what? This third plane or not? Yeah, but this one plane, this another plane, and back is what? Third plane. This common line of these two planes is a parallel to the third plane. So this kind of situation. But here, there is a knowledge of the matrices is going to help us. How do you know that? I just tell you that. See, guys, you have three equations. You have three equations, and these three equations are known as what? Homogeneous or non-homogeneous system of equations. Non-homogeneous system of equation. You write this into the single matrix equation. Ax equal to what? B. And you go for the what? Coefficient matrix determinant. If your coefficient matrix determinant is not equal to what? 0. Then you say you have a what? Unique solution to the xyz. That unique solution is known as what? Common point. That unique solution is known as a common point of how many planes here? 3 planes. If unluckily determinant is coming out of the 0, you will have infinitely many solutions, or else you may not have any solution. When you have infinitely many solutions, you will get a word. Common line or not? Yes. When you don't have any solution, you will get what? Triangular prism, because in a case of the triangular prism, you don't have any common solution of all the 3 planes. They go, we're just going to enter into the matrices. There's a linkage between the topics, basically. There's nothing, hidden actually. Yeah, that's only the point of interest to show here. That means that this way, you can pick up the word, information from here and there, and talk about the matter, right? Okay, well, and by the way, we can see the information of the straight line like this. Okay, a lot of things you are able to recollect of the straight lines. ठीक है, उसको जवाब दो. नेक्स्ट पॉइंट, बीच में डिस्टर्ब मत करो आदेश मिश्रा, ऐसे क्यों करते हैं? या there is a content name is called word. Straight line is done. Before that plane, you understand, you are able to recollect. And next is what? Sphere. It is a replication of what? Circle in 2D. It is a replication of the circle in 2D. Nothing is different. It is truth. Like, Iman से इसको फोटो भेजो. इसका भेजो. इसको हटाओ. इसको साफ करो. ये तो हो गया. भेजे भेजे. Yeah, see, next point. I just told the sphere is a replication completely of the word circle, nothing else. What are the properties you have in the case of the circle? The same properties to be done in the word sphere, nothing more than that, right? ग्रुप में, कौन सा ग्रुप में आप फोटो आएगा? कौन सा ग्रुप में भेज? जनरल वाला में भेजो ना. अभी नहीं डाला, भेजेगा लोग. राइट, डोंट वरी. Well, I just told somewhere, sphere is nothing but a locus. Because from a fixed point, with a fixed distance, you have a variable point. Right? It create a word. Sphere in 3D, circle in a 2D. Right? Kisne पूछ रहे? Please explain that last point. If determinant of A is 0, then what? No, determinant of A is 0. I won't speak so much. If determinant is going to be the 0, determinant is going to be the 0, you may have solution or may not have a solution to the unknown 𝑥𝑦𝑧. If you have a solution infinitely, many solutions. That time you will get how many solutions here? Infinitely many. That will be given by line. When you don't have any solution, you will get what? Triangular prism, that's what I'm saying. Because you don't have any common point, right? Just like you might be heard in the 12th class, augmented matrix. Rank of coefficient matrix, rank of augmented matrix. If you have been remembered, rank of augmented matrix, rank of coefficient matrix are same, will be equal to unknowns 𝑥𝑦𝑧, number of unknowns 𝑥𝑦𝑧. then given system is said to be consistent and have unique solution to the XYZ. If rank of the augmented matrix, rank of the coefficient matrix are same, but rank less than the number of unknowns XYZ, that time the given system is consistent, have infinitely many solutions. If ranks are not the same, then given system of equations are said to be the inconsistent and no solution. That way we see it's okay. Yeah. See, it's very simple that you understand. Sphere equation, circle equation is known as what? Locus. What is locus? You tell me here. Cp is equal to R. But in the case of the circle, what kind of properties you see? Of course, you can express the circle like this, but you can also express the, what kind of circles you can have here. General form you have, before that central form you have, you can have standard form you have. If my point, I'll be writing x1, y1, here is a xy, that's it, here is a r. And what is the central form? X minus x1 whole square, y minus y1 whole square, that is equal to r square. What is the standard form? Is that x square plus y square. Standard means that center is becoming a origin. This length is, fixed length is a radius. Is equal to r square. What is the general form? You tell me here. Just open it, will get a general form. X square plus y square plus 2ux plus 2vy plus some d, that is equal to 0, isn't it? It is known as what? General form. I'll write it back into this form as well. Okay. The same thing I can extend with what? This, I can say plus z square plus z minus z1 whole square plus 2x 2y plus 2wz plus d equal to 0. They are all becoming what now? Sphere. Sphere in the standard form, sphere in the central form, sphere in the general form. Isn't it? But sphere I can write with what? Diametric form also. Diameter means that, the card which is passing through the center will be known as a diameter. Right. I hope you understand. Yeah. But how many cards you can find here? Infinitely many cards. Okay. Yeah, it's okay. That's what the point. But in the case of the circle, you find a tangent line. In the case of the circle, you find a tangent line. But in the case of the sphere, you can find a tangent plane. In the case of the circle, you find a what? Tangent, line. In the case of the sphere, you can find a tangent plane at any point. What is the meaning of the tangent plane? You can try to say the plane which touches the sphere exactly at only one point, and such a plane is known as a tangent plane. The normal to that tangent plane 100% is passing through what? Center. The normal to the tangent plane 100% passing through the what? Center. But how many tangent planes you can find? Infinitely many tangent planes you can find. But I just ask you the question, through the point P, how many lines you really find? Infinitely many lines you can find. The locus of all these lines generate a what? Plane. Such a plane is known as what? Tangent plane. Right? The locus of all the lines will be known as a plane. That plane is known as what? Tangent plane, where it touches the sphere at only one point. Second, the normal to the tangent plane must be passes through the center of the sphere. Second, what is the condition to say this so and so plane is a tangent plane? The perpendicular distance from this plane to this particular point, distance must be equal to what? Radius. Then that plane is to be treated as what? A tangent plane. Again, I will recollect here. The perpendicular distance from this plane to this fixed point means the center of this sphere is equal to the radius, and that plane will be treated as what? Tangent plane. That's what I'm trying to say. Okay? Yeah. You might be studied in 12th that, the power of a point with respect to the circle. The power of a point with respect to the circle. The power of the point with respect to the word circle. Like the same way here, we can also see and study about what's power of a point with respect to the sphere. Lies outside, lies on, lies inside. Right? When you have greater than 0, the point would lie on outside. When you have equal 0, and you can say lie on. When you have a less than 0, lie inside. That's what you speak, if you have been remembered. Right? Somebody said right equation, S1 equal 0. Well, yeah. So the same properties we talk over here. What are those here? You tell me. The power of a point with respect to the sphere, which lie outside, which lie on, which lie inside. That's what you speak out. Okay. Along with that, you can also talk about in this sphere. In the sphere, is that, you know, a lot of information along with this information. That whatever you have studied in the circle, the same extension is going to become a case for the sphere. That's it. And I want to recollect one or two more results here. Is that, you know, I'll say, I have a sphere, right? I have a sphere. I have a word, line L. I have a line L, isn't it? I have a line L. What is it line? In symmetrical form or in any form, whatever. So next point, you can find many cards which are parallel to word. This particular line. You can find many cards, but those cards are layer of cards. You cannot find a line of cards. You can find in one layer. I'll find how many sets of lines here, how many sets of cards here, definitely many. But such set of, you know, cards, how many layers I can find? Infinitely many layers. My question is that if all these cards are parallel to this particular line, then find the word locus of the midpoints of all the cards and those cards which are parallel to this particular line, right? So is that something like this? The locus of all these, you know, the locus of all these midpoints of the cards and those cards which are parallel to the word, this particular line is going to give us what? A plane. This is going to give us what? A plane. That's what I'm saying. But, you know, see, this kind of information we can expand into the, you know, any level, right? It's one of the sample which I just wanted to say, right? And in this sphere, we can also have, you know, intersection of the two spheres. Intersection may happen externally, intersection may happen internally, right? Then what is the condition, right? What is a condition? The intersection is going to be happen with the word, with the perpendicularism. The intersection may not happen with the word perpendicularism. When the two spheres are going to be intersect each other, will the, in the word perpendicularism form or without perpendicularism form, right? Will they intersect at a, you know, at a 90 degree or else less than 90 degree? That's what the another case. And you might be heard about what, you know, yeah. In that case, the spheres are set to the word orthogonal spheres. That's it. You know, you might be heard about what radical plane. Have you heard about the radical plane? Okay, I just want to speak about that in one line, 2 lines. Is that when I have two spheres, S1 and S2, right? With these two spheres, you can have some point P. You can try to find a power of this point with respect to this sphere and with respect to this sphere. The power of this point with respect to this sphere and this sphere. If the power will be same, of this point with respect to both the spheres. But how many such points you have? Infinitely many points. If infinitely many points, whose powers may be same with respect to what? Both the spheres. The locus of all those points whose powers are the same with respect to the word, two spheres, will be known as what? Radical plane. Will give us what? A plane. Isn't it? Just like a sample of information, I just tell you here, I can write one of the sphere. Is that x² plus y² plus z² plus and 2ux plus 2v y man. Yeah. 2vy plus 2wz plus d is equal to 0. Next, S2 sphere xk plus y2 plus z2 and 2u1x plus 2v1y 2wz 1z plus d1 is equal to 0. When I can talk from these S1 minus S2. What is my S1 minus S2? You tell me. Right? S1 minus S2. If I write from this xk, y2, z2 is cancelled. I'll get through what? 2 into u1 minus u minus u1 x, 2 into v1 minus v minus v1 y plus 2 into w minus w1 into z and d minus d1 is equal to 0. Will it be plane or not? This kind of plane is in future I can talk as radical plane. I told power is nothing but, maybe greater than 0, maybe less than 0. If you can ask me in one line, your S1 equal to 0, or else just I want to say S1 value. S1 value, what do you mean? If you ask me, it is my sphere. If my P point is going to be x1, y1, z1, isn't it? Then this name you can say as S. What is going to be happen? What is the S1 stands here? x1 square, y1 square, 2u, x1, 2v, y1 plus 2w, z1 plus d. This is known as power. But right now I don't want to say anything. Right. Power of which point? It may be greater than 0, maybe less than 0, maybe equal to 0. Vaibhav, is it correct? Say yes, no? Yeah. So finally, I'm saying that we'll also learn about the word radical plane. Okay. So two spheres together will generate the word system of spheres. Two spheres together will generate the word system of spheres. But before that, I would like to say, before that I would like to say, if a plane cuts a sphere, if a plane cuts the what? Sphere, isn't it? If a plane cuts a sphere, it is a sphere. A sphere center is something like here. If a plane cuts a sphere, you'll get the word circle. Circle is represented by one equation or two equations? Two equations. One is what? Sphere, another is what? Plane. But in 2D geometry, circle is represented by equation. In 3D, circle is represented by equation, sphere and a plane. If this plane cuts a sphere through its center, such a circle is known as what? Great circle. Can I ask you one question from all of you? In a general equation of the sphere, I forgotten to ask you, x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal 0. To represent it is a sphere, first criteria is that coefficient of x square, y square, z square must be same. I can't say it's 1. Must be same. Next, in the general equation of the sphere, effectively, how many arbitrary constants can work?
3.
4. How I say 4? U, V, W and D. I can't disturb the D also because my condition, I told you very first, my condition is that my coefficient of x square, y square, z square must be what? Same. When it is same, then obviously I can't disturb the D also. In the case of the plane, you can disturb the D and come down to the what? 3 arbitrary constants effectively. But in the case of the sphere, you can't disturb the d and you can't come down to the 3 arbitrary constants. It means that how many arbitrary constants you can get here in the general equation of the sphere? 4. That's the reason I can clear the unknowns. What are my unknowns? U, V, W, Ds. To know the 4 unknowns, it has to pass through what? 4 points. Or else it is to be associated with the how many conditions here? 4 conditions, then I clear. Otherwise I can't. So that's the reason. Sometimes in the future I can say the 4-point form of the sphere. 4-point form of the sphere. That's for the case you understand. Of course, we have a diametric form of sphere also, but I'm not able to open that. But that's fine. But I just told, by the way, your S is equal to 0 and pi is equal to 0 represent a circle or not? Represent a circle, isn't it? Represent a circle. Okay. Somebody said if it passes through the origin d0. That is a particular case. Okay. I mean, in general, I'll have to speak here. Yeah. Next point. Somewhere you told just before a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0. These two are the planes or not? Pi 1 and pi 2. These two are the planes. Two planes together generated what? The two planes together generated what? Line. Two planes together generated what? Line, isn't it? Two planes together generated what? Line. That's what you've been seeing just earlier, isn't it? Yeah. When I go to the case of two planes in the form of the book, created a line. Through this line, how many planes you can find, man? Infinitely many planes you can find. This plane is a plane through the line of intersection of the two planes. This plane is a plane through the line of intersection of the two given planes, isn't it? Yeah. So, like the same way, please you agreed with me that two planes together generate what? Line. Through the line of intersection of the two planes, I can have infinitely many planes. But this plane I can clear by passing through the point or by in association with some other condition. Right. So if that is the case, you can observe so well, it is a sphere. When you cut this sphere by knife is nothing but a plane. It created what? Circle. It created what? Circle. Now what I'm asking you a question, if I just write mathematical equation, what happens here? You can write x square plus y square z square minus r square is equal to 0, it is s. And plane pi is that ax plus by plus cz plus d is equal to 0. And these two equations together known as a circle, right? When my plane cuts a sphere, I got a circle, that representation of the circle given by the two equations. Next point, you just understand, so simple. Through the circle of intersection, just like I told, through the line of intersection of the two planes, I found again planes. Through the line of intersection of the two planes, I found again a plane. Like the same way, of course I found a circle. Through the circle of intersection, do I find again a sphere or not? Through the circle of intersection, I again find what? Sphere. That sphere would be represented by s plus lambda pi is equal to 0, right? But by keep on changing my lambda, how many spheres I can get here? Infinitely many spheres I can get. That is the reason I can say this is a family of the spheres through the circle of intersection, isn't it? Then what is the radius of this particular circle? What is the center of this particular circle? This kind of, again, what is the tangent line to this particular circle, right? family of these spheres. Isn't it? Yeah? So this way we have a lot of properties in the what? Sphere as well. Just we can compare and extend the what 2D circle into the 3D sphere. Nothing more than that. Okay, इसका photo भेजिए क्या? Yeah. After this, we'll get into the idea of what? Cone and a cylinder. Right. Cone and cylinder is the same as what? Sphere properties. Cone and cylinder is the same as what? Sphere properties. I just say something about cone and cylinder. अभी time कितना हो गया? Time बहुत हो रहा है. Shall I complete the complete cycle of this information? Online guys? Online में कितना है? अच्छा. Yeah, I'll tell. It's easy. Okay, I'll try to finish bit short. Right. Cone and cylinder. I just told that. Cone and cylinder is the same as which properties here? Sphere. Nothing else. I'll find a cone chapter. Sorry, the cone formation like this. This particular point is a fixed point. Fixed point. Fixed point. I can just have a fixed vertical line. What is that fixed vertical line here? Something this. Fixed vertical line. Yeah. It's a fixed vertical line. Yeah, it's so correct. ऑफिस जाना है. बच्चे का ऑफिस टाइम हो रहा है. Yeah, it's well. Shall I just finish it shortly or else? Because it's nothing. But my point of view to see how much it is easy, how easy it is, and a lot of people have faced a problem. Up to the cylinder, cone cylinder, everybody is happy to read. When it comes to the 𝐴 is not a bad chapter. It's a good chapter, but it's lengthy. All what you studied contents, same contents will repeat in the 𝐴. But I'll tell you shortly, please. Right. Somebody said, GS class hai. Kya baat hai? Yeah, it's okay. I think we'll stop it. But otherwise, I'm saying that, shortly, regarding this 𝐴, एक इक्वेशन लिख के मैं छोड़ दूँ, राइट? एक इक्वेशन लिख के मैं छोड़ दूँ, राइट? किसके बारे में बताओ? 𝐴 के बारे में. 𝐴 के बारे में. I just write one equation. Okay. What is that? I think you might be seen ax square plus by square cz square 2gzx 2hxy and 2fyz plus 2ux plus 2vy plus 2wz plus d equal 0. And have you seen this equation anywhere? Yeah, we have seen this equation. I told this equation the pair of planes. Right? It represents the pair of planes when my determinant was equal to what? 0. What is that? AG, and then what? BC, FF is equal to what? 0. You'll easily remember. What is its final equation? If you really express it, ABC plus 2FGH minus F square minus B square minus C square is equal to 0. If it satisfies, I was saying, this represents the two planes. That's what I'm saying, pair of planes. Next point. I can say, if I just only up to this, if I write, I don't want to write this. It is homogeneous part. This also represents a pair of planes passing through the origin when again this determinant is equal to 0. When I just have only this equation, mean that ax k, by k, cz k, 2gx, 2hxy is equal to 0, then that is known as what? Homogeneous equation. Every homogeneous equation represents a cone with vertex at the origin. This becomes what? Origin. But how that is, I'm not able to say right now. It's okay. Well, and again, if I take this whole equation, not up to this also may represents a cone with vertex at a non-origin. Maybe x1, y1, z1. I'm saying that may represent, I'm saying. Right. Carefully mind here. But in the case of the cone, there is nothing to discuss with this. In the case of the cone, just enough to discuss with the homogeneous condition. Right. Second, I would say that in this general equation, effectively, how many RB constants you can have in this general equation? In this general equation, effectively, how many RB constants you can have?
9.
In generally, you can find 10, but out of the 10, 9 can work effectively. What are those? ABC and FGH, UVW, total 9, and plus D, 10. I can kill one of the constant. It does not impact anymore. Effectively, how many can work here? 9 can work. To clear the 9 RB constants, it is enough to pass through what? 9 points. Or it is enough to associate with what? 9 conditions. 9 conditions, isn't it? Next point. But see, I can create a sample of the information. From this, do you get a plane or not? I'll get what? 2ux plus 2vy plus 2wz plus d equal to 0. Will it be a plane or not? What do you mean that? Your ABC, FGH will be considered as a zeros. How do I get a consideration on the zeros? Maybe it is passing through 9 points. I may get a plane. Or I may get a what? Sphere. What is sphere here? xk plus yk plus z square is equal to what? 1. What do you mean that? My ABC I took as 1. My FGH values took as 0. And UW is, so not ABC. ABC will be taken as 1. Rest all will be 0. D is equal to -1. And no, not only that. Do you get this ellipsoid or not? You'll get ellipsoid. What is it ellipsoid? Xk by a square, yk by b square, zk by c square. That is equal to what? 1. You'll get a hyperbolic paraboloid or not? Right? Elliptic paraboloid or not? Yes. So you can get every kind of surface. But what kind of surface you can get? Any kind of surface, every kind of surface. I just told somewhere sample is a plane, sample is a sphere, sample is a ellipsoid, sample is a pair of planes, sample is a cone, sample is anything else. So which surface produces many kinds of surfaces will be known as a conicoid, shortly 𝒔𝐿. Seriously. आदमी गिरगिट हो सकते हैं क्या? तो आदमी गिरगिट से ज़्यादा ही है, राइट? हर दिन हर मिनट में उसका मतलब आदमी तो वो एक ही है, राइट? उसका कैरेक्टर मुंह बदलते रहता है या चेहरा बदलता रहता है, बहुत कुछ है, राइट? सो कैन वी ट्रीट दिस ह्यूमन इज अ conicoid? Yes, human is a conicoid. He changes a lot in every moment, in every situation, right? So which surfaces produces infinitely many surfaces, and such a surface is to be treated as what? Conicoid. But again in the conicoid, do you able to see all the same informations or not? Along with that, you can see extra information is nothing but ellipsoid. I put 1 sheet, I put 2 sheets, or else elliptic paraboloid, hyperbolic paraboloid, many other sort of surfaces. These are some known surfaces which I am spelling. There are many unknown surfaces also possible. Along with this, in this, whatever the discussions we take over here, these discussions anyway will come again, repetitive. Along with that repetitive of these informations some new information will come. Shortly I can say, one name is a generating line. Generating lines. You see, Can you imagine my body shape is a hyperbola one sheet? अरे इधर आओ इसको हटा दीजिए. Can you imagine one information I can tell you shortly? And my body shape. No, Akhil, it's going to be about to close. Don't worry, Akhil, shortly. X is k plus y, x is k by a is k plus y is k by b is k minus h k by c is k, that is equal to 1. It is a hyperboloid of one sheet, right? And only one axis will be imaginary axis. Can you imagine that information is like this? Which axis is imaginary axis? Can you tell me? Z axis, since you have a minus. How can I say? If x and y will be 0, my z is going to be what? Plus minus e. Isn't it? I'll get a surface name like this if you really allow me. Well, isn't it? Which axis cannot intersect this surface? Z axis cannot intersect, man. Z axis, it's not going to intersect anywhere. Imagine, it is origin. But see, this is what a surface is given by this mathematical equation. Just I'll ask you simple. Take me an example. Take the example of my shirt. But this shirt is made with the vertical lines and the horizontal lines. I'm speaking lines. Right? That means that locus of vertical and horizontal lines made the shirt. But when I wear the shirt on my body, it has been adjusted according to my body. Right? Imagine. Right? Can you imagine this? This surface is my body surface. Yeah, you can try, but iska chodo, baki, theek hai. And you can imagine. And that means that I am trying to say here, these lines, the vertical and the horizontal family of the lines, made the what? This surface, isn't it? But these lines turn into what? Curve structure. That's the reason sometimes I can say in future ruled surface. Right? Second, these lines will be known as a generating lines. It's what one of the standard information I'm saying. Otherwise, you can find with any other information also. These lines will be known as a generating lines. So see, really, the generating lines is very interesting up to some set of problems. After that, like 7 or 8 problems, I believe, 8 on the worst case. Okay. After 8 problems, then if you know the 8 problems, then the rest problems you are able to do, otherwise you can't. Because all previous 8 problems are going to be mixed with the next questions. Sometimes you have to remember the steps. That's where the challenge comes to you, right? There's a content name called, reduction of these second degree equations. Like this conic-eyed equation, we can reduce towards something else. This conic-eyed equation transfer towards some new form. The new form is known as the standard form. The new form is known as a canonical form, a normal form. Whatever the new forms we bring out, their names are nothing but canonical form, normal form, standard form. That's what we say. This way, the things to be taken up. Okay. So I don't think so you face any problem. Only systematic learning is required. And do hard work. We'll see tomorrow fresh. And we'll begin from the beginning. And it's not very difficult chapter. Try to, like this chapter, then you will learn nicely. Okay. Thank you. We'll see tomorrow. Wish all the best.